Hello my dear students, welcome to my YouTube channel, that's Concepts of Chemistry. Before starting today's lecture, please do subscribe my channel. My dear students, today's topic for the lecture is the general characteristic of the p block elements. So let's understand first what's the p block of the periodic table. Let's come to the periodic table first. Here the elements which are shown green in color belongs to the p block. I have marked the p block with the black box. You can observe that very easily. So what is p block? When the last electron of any element enters the p subshell, then that element will belong to the p block of the periodic table. So the group number 13 to group number 18 will belong to the p block, and these are like I'm writing is the group number 13, group number 14, group number 15, 16, 17 and finally 18. And here the exception is of helium. Helium has a general electronic configurations 1s2, but the properties of helium matches with the noble gases. That's why we have placed the helium with the group number 18, that's of noble gases. Now the general electronic configuration of the p block is ns2 np 1 to 6. Now we are having certain names of all the groups of the p block. That's the group number 18 is called noble gases, we all know that. The group number 17 is called halogens. The group number 16 is called chalcogens. The group number 15 is called nitrogen family. The group number 14 is called carbon family. And lastly, the group number 13 is called boron family. So I have written some points. Let's read them one by one. The very first point. The p block element consists of 6 groups, that is from group number 13 to group number 18 of the periodic table. Let's come to the second point. This block consists of metals, non-metals as well as metalloids, due to which the chemical properties varies for every group. Let's come back to the periodic table again. I am marking the metalloids. What are metalloids? The elements which have properties of both metals as well as non-metals. So here metalloids are boron, silicon, germanium, arsenic, tin, is antimony, tellurium and astatine. The metalloids are boron, silicon, germanium, arsenic, antimony, tellurium and the astatine. Now these are the metalloids. The element which are present on the left side of the metalloids, that's aluminium, gallium, indium, thallium, tin, lead and the bismuth. These are all metals. Now the elements which are present on the right side of the metalloids, and these are carbon, nitrogen, oxygen, fluorine, phosphorus, sulfur, chlorine, selenium, bromine, iodine. These are the non-metals. The group number 18 is noble gases, so we don't consider them in metals or non-metals. They are inert gases. So I hope you got the point that the p block consists of all the metals, non-metals as well as the metalloids. The metalloids are boron, silicon, germanium, arsenic, antimony, tellurium and the astatine. Polonium is also a metal. Now let's come back to the points. The point number 3. Most of them are highly electronegative elements, and electronegativity increase across a period and decrease down the group, as electronegativity is dependent on the effective nuclear charge, and these trends which we are going to discuss in the next lectures. Now let's come to the fourth point. Many elements of the p block show allotropy. The carbon, silicon, phosphorus, sulfur, boron, germanium, tin, arsenic, etc. show this property. As we all know, the allotropes of carbon are diamond, graphite, and the Buckminster fullerene. For the sulfur, we are having the monoclinic sulfur, the rhombic sulfur. For phosphorus, we are having the red phosphorus, black phosphorus, alpha black phosphorus, beta black phosphorus, and so on. Now let's come to the fifth point, the catenation property. Ability to form bonds with itself to form the long chains. That's called catenation property. The catenation property is also shown by many members of this block, such as the carbon, silicon, germanium, nitrogen, etc. Now let's come to the sixth point. No member of p block imparts any characteristic color to the flame as the elements of s block do, but the member of p block will not impart any characteristic color to the flame. Let's come to the seventh point. The p block elements generally form covalent bonds, but the higher members can form ionic bonds also. What do we mean by the higher members? Higher members stands for the elements which are present at the bottom of any group. That's called higher members, and they can form ionic bonds because they are metallic in nature. What's metal? The elements that have a high tendency to form cation. If we are getting cation, so they can form ionic bond with any another anion. So the p block elements generally form covalent bonds, but the higher members can form ionic bonds also. Now let's come to the eighth point. The members of this group form acidic, basic, neutral, and the amphoteric oxides. As this p block consists of metals, non-metals, and metalloids, so they can form all types of oxide, that is acidic, basic, neutral, or the amphoteric. I'm reading next. As we move across a period, when we move across a period, non-metallic character increase, due to which the acidity of oxide increase. When we move across a period, the non-metallic character, that is tendency to form anion, will increase. So due to which the acidic character of their oxide will also increase. As we move down a group, metallic character increase, that is ability to form cation increase, the oxidation state increase, due to which the basicity of oxide will increase, as the metallic oxides are basic in nature, which we have done in the previous lecture. Now when we come across the metalloids, the amphoteric character of any oxide increase. What do we mean by amphoteric oxides? The oxides which can react both with acids and bases. And what's the neutral oxides? The oxides which does not react with any acid or a base, that's are neutral oxides. So let us discuss this eighth point in detail. I'm taking some examples of oxides. Let's take the example of carbon. First of all, carbon is a non-metal. The oxide of carbon will be C plus O2. It's gonna form me CO2. The CO2 is acidic oxide. How can I say the CO2 is acidic oxide? Because CO2 reacts with water to form an acid called carbonic acid. We got an acid H2CO3. It's a acid, and this acid is called carbonic acid. So the CO2 on reaction with water has formed an acid, that's why CO2 is an acidic oxide. Let me take an example of nitrogen. The oxide of nitrogen, I'm taking it to be N2O5. That's a nitrogen pentoxide. It's an oxide of nitrogen. When this nitrogen pentoxide reacts with water, it forms HNO3. I am not balancing the equation because I am concerned with the concept only. So it's an HNO3. This is an nitric acid. So nitrogen pentoxide has formed an acid with water. That's why N2O5 will be again acidic oxide. And again, nitrogen is a non-metal. Let me take an example of another non-metal oxide, that's sulfur. I'm taking the example sulfur trioxide. The sulfur trioxide on reaction with water forms H2SO4, that's sulfuric acid. that's sulfuric acid. So sulfur trioxide on reaction with water has formed the sulfuric acid, so we can say that the sulfur trioxide is also an acidic oxide. Let me take an example of phosphorus now. I'm taking example to be P4O10, that's oxide of phosphorus. This oxide on reaction with water forms H3PO4. H3PO4 is phosphoric acid. So again it's an acid, so P4O10 is again acidic oxide. And again phosphorus is again a non-metal, sulfur is also a non-metal. Now let's take an example of any halogen. I'm taking the oxide of chlorine, that's Cl2O7. Cl2O7 on reaction with water forms HClO4, that's perchloric acid. Perchloric acid. Now was chlorine. Chlorine is a non-metal, and oxide of chlorine has formed me an acid, that's why Cl2O7 will also a acidic oxide. Now let's take an example of amphoteric oxide. Now I'm taking an example of amphoteric oxide. For that thing I have to take any metalloid. I'm taking any amphoteric oxide. What are amphoteric oxides? The oxides that reacts with both acids as well as bases. The oxides that reacts with acids as well as bases, that's amphoteric oxides. Let me take an example. Aluminium oxide, that's Al2O3. Al2O3 when reacts with any acid, let me take an HCl, so it's an acid, so here Al2O3 will act as a base and it will react in presence of water to form aluminium H2O6 times and a Cl, here is 6 and is 2, so it has formed an coordination complex. So here it has reacted with acid. When Al2O3, when any oxide reacts with acid, then that oxide will act as a base, so in this reaction Al2O3 is acting as a base. Now let us react Al2O3 with any base. I am taking Al2O3 and I am taking this reaction with any base. Let me take an example, NaOH. I am not balancing the equations because I have to concern with just a concept, so please don't worry about that. So here NaOH is a base, so Al2O3 will act like an acid over here, and in presence of water Al2O3 will react with a base and will form you sodium meta-aluminate, that's Na3AlOH6 and bracket closed. So here you can see that Al2O3 has acted like a base when it reacts with acid, and Al2O3 reacts like an acid when it reacts with a base, means Al2O3 is reacting with both acid and a base, that's why Al2O3 is an amphoteric oxide. Now let's come to the metallic oxide. let me take any metallic oxide. uh, let us take an example of metal which is present in p block, and that's a thallium. I'm talking about the thallium. It is a metal present in p block, present in p block. So the oxide of thallium will be basic in nature. That is, I'm taking the example Tl2O. That's a thallium. It will react with acid. Acid is HCl, so thallium will act as a base over here, and it will react with acid to form thallium chloride and the water. So here thallium oxide is acting like a base, so it's a basic oxide. Now let's talk about the neutral oxides. I'm talking about neutral oxides. What are neutral oxides? The oxides which neither reacts with acids nor with bases. The example of neutral oxides are carbon monoxide or nitrogen monoxide, CO or NO. So that's all for today. I hope you all understood today's lecture. If any student wants to book a paid one-to-one online class to clear their doubts, then she can contact me. My phone number is mentioned on thumbnail of this lecture. Please do like, subscribe and share this channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.